All right.
Both of you. Woo. Up you go.
Here's a view from one of the windows in the cupola. You can see, if you look at the Earth, you can see this is the direction we're going. Usually the station flies with the U.S. side forward. This is the Russian side you're looking at, and we're upside down, basically. And while the shuttle's attached, that's the direction that we fly. And what you're looking at here is a progress vehicle. That's the Russian cargo vehicle. It's a fully automated rendezvous and docking, and then brings up on entry cargo vehicle. You can back up manual fly it from the service module, and the service module, the command and control center for the Russian segment, is back there. It's the next module, and then behind that is the European ATV, automated transfer vehicle. It's the one with the solar panel that's going up at an angle there. And what you see here on top of the FGV is a new Russian module. It's a research module. And below the Progress is called a docking compartment, or SOID. You can see there's a little hatch on it with a window. There's one on the other side as well, and they do their spacewalks from that module. So this is a module that used to fit inside we had many of these that flew inside the shuttle cargo bay and brought up logistics with it, and this one was modified to stay here permanently. So it's a very nice space, and we've been using it for our EVA preparations, and it's a lot of cargo in there. It's a very nice space to have. You're looking at the U.S. laboratory there. Attached to it is Dexter, the robot from Canada. It's also called SPDM, Special Purpose Dexterous Manipulator. It's got 2 arms, and it'll be able to do replacement tasks outside the station. As you can see, a couple of things attached to it. Of course, there's the shuttle and the Earth behind. Very beautiful. And then coming out the other side is the JAM, the Japanese Research Module, and in front of that is the JEF, the Japanese Exposed Facility, where a lot of research experiments are conducted. And there's a robotic arm sticking up there. You can see just the end of it. And that arm can actually move things in and out of an airlock at that end of the Japanese module. And you see the beautiful solar panels there, 240 feet from tip to tip, extending out one side.
Endeavour continues to fly around the station, the International Space Station, stretching 357 feet from tip to tip. The pressurized volume, perpendicular volume there is about 240 feet. At the bottom, the docking port from which Endeavour departed the European Columbus Science Laboratory off to the left, and the Japanese experiment module Kibo, the Japanese word for hope, off to the right. And then heading down the length of the volume, the Harmony connecting node to which those modules are attached, in turn is attached to the U.S. laboratory Destiny. Atop Destiny is the center point of that almost 360 degree or 60-foot long truss structure. And then the first U.S. element of the International Space Station launched back in December of 1998. The Unity module is the connecting point from the U.S. segment to the Russian segment of the station. Next in line, the first ever component of the International Space Station, the Zarya control module, with its solar arrays mostly retracted in accordion style. The Zvezda module on the back end is the next module with its solar arrays deployed, served as the early living quarters and the control section of the Russian segment of the complex. And then on the back end with the scissor-shaped solar arrays is the European Space Agency automated transfer vehicle known as the Johannes Kepler. It's been a part of the space station since late February when it arrived delivering supplies to the station. It's one of several visiting vehicles that the station hosts, including the Russian Soyuz capsule, which delivers crews to and from the station, and also the Progress supply vehicles